Hello students, today we are going to discuss about the anomalous properties of nitrogen. Anomalous property means the difference or differ in the properties of nitrogen from the rest of the member of group 15 element. That means nitrogen has some different properties from the phosphorus, arsenic, antimony and bismuth. Okay, now what is the reason of this difference in property, or you can say anomalous of property, is mainly due to the four reasons. Okay, first reason is the small size. Second reason is the high electronegativity. Third reason is the high ionization enthalpy. Fourth reason is the non-availability of d orbital. Non-availability of d orbital. These are the four reasons of anomalous properties of nitrogen. Okay, now see some properties. What are the anomalous properties? Okay, this is the reason, but what are the anomalous properties? First one, see, point wise, that's right. Okay, I'm writing point wise. Nitrogen can form p-pi bond between itself or with other element. Between itself or with other element. This other element is mainly carbon and oxygen. Now what do you mean by p-pi bond? Okay, I already explained in class 11. Now I am again here explaining. P-pi means p orbital is involving in the formation of pi bond. Suppose this is the 3p orbital. Suppose this one is px, this one is py, and this one is pz. Now here is the another p orbital. Suppose this one. This one suppose py, this one suppose px, and this one suppose pz. Now it forms the lateral overlap. By the lateral overlap, it forms the pi bond. Suppose this one. Okay, by this 3 p orbital, it forms 3 pi bond. That's why it is p-pi bond. Okay, next property. So the next property is the heavier element. Okay, heavier element means which one? Heavier element means the element which have high molecular or atomic mass. Mainly these are phosphorus, arsenic, bismuth, antimony. These are heavier element cannot form p-pi bond. Now what is the reason? Because of its bigger size, because of their, you can say, large size. Now why this large size is responsible to not form p-pi bond? Because of the large size, it cannot form effective overlapping. See how I'm writing, okay? Because size, they cannot have effective overlapping. Effective overlapping, okay? Effective overlapping okay? Thus only nitrogen can have nitrogen triple bond. Nitrogen triple bond, okay? Having a very high bond enthalpy, having bond enthalpy is nearly 941.14 kilojoule per mole. This 941 kilojoule means very high bond enthalpy, and high bond enthalpy means the bond is very strong, okay? Now see the next property. Next property. Next property is very interesting property, okay? Nitrogen single bond. That is single bond, no? Single bond is weaker. You might be thinking that nitrogen due to a smaller size and high electronegativity, this bond may be very strong, but it is observed that practically nitrogen single bond is weak bond than the weaker than PP phosphorus bonds, arsenic bond, antimony bond, and bismuth bond. Why? Because of inter-electronic repulsion of non-bonding electron. Now see, suppose this one nitrogen, okay? Suppose this one nitrogen, and here is another nitrogen having nitrogen single bond. Now there is two other electron, no? Non-bonding electron. This non-bonding electron is repulsed to each other and forms a weaker attraction between this nitrogen and nitrogen. Now, why this inter-electron repulsion is higher in case of nitrogen? Because it's small size. If it is small, then obviously this electron, that is non-bonding electrons, will remain close to each other. Okay. Now, but in case of phosphorus, see, phosphorus is bigger. There is another phosphorus, another bond. See, the distance between these two and these two increases, no? That's why here the repulsion decreases. Repulsion decreases. If repulsion decreases, then obviously the stability will increase. Okay. See the next property. Except nitrogen, all other element can form d pi p pi bond. D pi p pi bonds. Why nitrogen cannot? Because its unavailability of d orbital. That's why it cannot form d pi p pi bonds. D pi p pi means d orbital and the p orbital is using to form a pi bond. That's why d pi p pi bond. How? Let's take an example. Suppose R3p oxygen. R3p oxygen. Now here, see. Now here, phosphorus is bonded with 3 R group. R means maybe alkyl or aryl. And another oxygen is bonded with phosphorus. Here, suppose P is sigma bonded with 3 R group, no? 3 R. But here also, this 4 are sigma bond, but this one is pi bond. This pi bond occurs due to the overlap of d orbital of phosphorus and p orbital of oxygen. Now see how. Suppose this one is p orbital. This one suppose phosphorus. And d orbitals looking like this one. Suppose a d orbital of p. But here p orbital of suppose oxygen. P orbital of oxygen. Then obviously it can form pi bond, no? This one of d orbital of phosphorus, this one p orbital of oxygen. That's why this pi bond, lateral overlap forming this type of pi bond. That's why it is name of d orbital and p orbital. But it is pi bond. That's why d pi p pi bond. Okay. See next property. Next property is the some trends of property. Some trends of properties. Trends means how their properties is decreasing or increasing. Okay, we have to explain the decreasing, increasing nature of some properties. See first one. First one, suppose stability of hydride. Remember, when this type of element of group 15 react with hydrogen, it forms the hydride. Now we have to discuss how the stability of hydride increases or decreases down the group. Now see. First one is the stability of hydrate. Stability of hydrate. Now the hydrates are these are NH3, PH3, arsenic H3, antimony H3, bismuth H3. These are the hydrates of group 15 elements. Now see. As from nitrogen to bismuth, the size of the atom, that means the group 15 element, is increases, no? If size increases, then their tendency to form the covalent bond with hydrogen also decreases. Now see. Suppose this one nitrogen and this one bismuth. Size is increases. But hydrogen remains same, no? Suppose this one hydrogen. Now see, internuclear distance between these two, this one. But here, suppose if this one is hydrogen, then distance is this one. As you know, more the distance, lower the stability. So obviously, the bond strength here it is stronger, and here the bond strength is weaker. That's why the stability of hydrides of group 15 elements decreases from down the group. That's why this one is more stable, then this one, and this one. Reducing character of the hydrates. Now see. Reducing character means, now what do you mean by reducing character? Reducing character means it reduces other, but itself oxidize. Itself oxidize. Now oxidize means losing of electron. Losing of electron. Now see here. Okay. Now see here. Nitrogen is there. Other bond is also there, but I am taking only one. Nitrogen is bonded with hydrogen. Here also, bismuth is bonded with hydrogens. Here the bond distance is small, and here bond distance is high. That's why it is weaker bond and it is stronger bond. Now see, if it is stronger, then obviously the removal of hydrogen, that means minus hydrogen, will not be easy. This is difficult because there is strong bond, but here is due to the weak bond between the bismuth and hydrogen, it can be easily removed hydrogen. If hydrogen is easily removed, that means it oxidizes. If it is oxidized, then it will reduces the other. That's why this one is a stronger reducing agent, this one is the weaker reducing agent, and the trend is this way. Okay. Next is the basicity. Basicity. That means you can say basic character. Basicity. Now basicity means what? Basicity means what? See. Now see. From nitrogen to bismuth. Nitrogen to bismuth, due to increase in size, the electron density over the element. Element means here the nitrogen, phosphorus, arsenic, bismuth and antimony. Bismuth, these are element. Element decreases. If it is the electron density on the 15 group element is decreases, then obviously the electron giving tendency will decrease, no? According to Lewis concept, electron giving, then it should be what? Base. Electron accepting, it should be acid. It should be acid. Now we are discussing about the basicity. That means we have to discuss about the electron giving tendency. As we are going from nitrogen to bismuth, the electron density on the central atom, that means nitrogen, phosphorus, arsenic, these atoms are decreases. That's why the electron giving tendency also decreases, and the basicity character also decreases from nitrogen hydride to bismuth hydride. That's why this one NH3 is a more basic, then PH3, then this one. Okay. Now see the next. These are the hydride. Now we are going to discuss about the oxides of group 15 elements. Okay. Oxides. Element. oxides of group 15 elements are of mainly two types. First one is the E2O3 and E2O5. In this E2O3, E means the group 15 elements. E are in +3 oxidation state, but here it is +5 oxidation state. Okay, now see. First point from this oxides. Okay, higher oxidation state oxides. That means the oxide having higher oxidation state is more acidic than the oxide having lower oxidation state. Now why? Suppose we are taking this one +3 oxidation state, this one +5 oxidation state. Now see, +3 means what? It +3 means it has less 3 electron, but here it is +5. That means it has less 5 electron. Now if it is less 5, then obviously this compound have the more tendency to take or to gain electron from the other source. Now if this species or this compound takes the electron from the other source, then it will become acidic, no? That's why +5 oxidation state, that means higher oxidation state, is little bit higher acidic than the lower oxidation state, because it has the less tendency to attract or to gain electron from other sources. Okay. Now come to the this one. That means E2O3. E2O3 is the most common oxides of group 15 element. Now, acidic character of E2O3. Acidic character of E2O3. Now acidic character of these oxides, that means E2O3, is decreases down the group. Suppose N2O3 is the most acidic, then P2O3, then AS2O3, then SB2O3, then Bismuth2O3. Okay, these two are acidic and these two are amphoteric. Amphoteric means in some cases it behaves as acid, or in some cases it behaves as a base. That's why it is amphoteric. But this one is purely basic. This one is purely basic. Now why? Reason is what? Due to the increase in size from nitrogen to bismuth, okay, the tendency to accept the electron is decreases. That's why this becomes the higher acidic and it becomes the lower acidic. That means basic. Okay. See the next. Next is the reactivity towards the halogens. That means how the group 15 element is reacting with the halogens and what are its properties. Now see first. Suppose group 15 elements forms two types of halogens. First one is the EX3 and another is the EX5. Okay. Remember, EX5 does not form for the nitrogen atom here except nitrogen, because unavailability of d orbital. Now see, Main thing from the halide is which one is ionic or which one is covalent, or you can say which one is more ionic or more covalent. Now see. First of all, let us compare between these two. Okay. Pentahalide. Pentahalide, that means this one, no? Pentahalide are more covalent than trihalide. Pentahalide are more covalent than trihalide. Why? Suppose I am taking a species, any species. Okay. Here it is +5 oxidation state. Here is another species having +3 oxidation state. Now see. Here it is +5 means what? It has it has 5 electron less. And here 3 electron less. But remember, the protons remain same. Protons remain same. Now, if the protons remain same, then obviously the polarizing power will increase, no? Their polarizing power will increase. Now, how can you explain the polarizing power increases? Now see. Suppose here, I am assuming that here 15 proton is there. Proton plus, P plus means proton. But due to its 5 positive state, it becomes 10 electron, no? 15, 10. But here 15 proton but 12 electron. Now see, if we compare these two, here the polarizing power is, suppose we are assuming 15 minus 10 is 5. But here polarizing power should be 15 minus 12 is 3. That means here the polarizing power is higher than this one. Due to this higher polarizing power of this one, that means 5 plus 5 state, it can polarize the molecule easily. That's why it becomes what? Covalent, and this becomes little bit less covalent, or you can say ionic. Okay. Now let us compare between this one, EX3. EX3. The halides are, suppose, NX3, PX3, ASX3, SBS3, and last one is Bismuth X3. Now see, from NX3 to Bismuth X3, the covalent character, which one? Increases. The covalent character increases. Covalent character increases because as the size increases, their polarizing power is decreases. As the size increases, their polarizing power is decreases. That's why covalent character is increases. That's why this one is ionic, but this one covalent. Okay, this one is ionic, this one is covalent. Thank you.